Hey guys, these are the 6 trigonometric derivatives. If you're learning this right now, you're probably pretty comfortable with sine and cosine, but you might not be familiar with how these 4 are derived. So first, let's do tangent x. So we know that tangent of x is equal to sine x over cosine x. So we're just going to take the derivative of that. In this case, we have a function divided by a function. So we're going to use quotient rule. I remember quotient rule as low d high minus high d low over low squared. And you've probably remembered something similar to this. The low is going to be this lower function, which is cosine x. D high is the derivative of the top function, and derivative of sine is cosine. The high is going to be the upper function, which is sine, and then the derivative of low is going to be the derivative of cosine, which is negative sine. And low squared is going to be cosine squared. Cosine x times cosine x is cosine squared x. This negative times this minus gives us a plus, and sine x times sine x is sine squared x. And this is all still over cosine squared x. Now the trigonometric Pythagorean identity says that cosine squared plus sine squared is equal to 1, and this is still over cosine squared x. 1 over cosine is secant, so 1 over cosine squared is secant squared. And this is the reason why the derivative of tangent of x is equal to secant squared x. How exciting. Next, let's do the derivative of cotangent of x equals negative cosecant squared x. By definition, cotangent of x is equal to cosine x over sine x. So we're going to take the derivative of that. This is going to require quotient rule, and I remember that as low d high minus high d low over low squared. Low is going to be the lower function of sine x. D high is the derivative of this top function, and derivative of cosine is negative sine. High is this top function, which is cosine, and derivative of low will be derivative of sine, which is cosine. And then low squared is sine squared x. And now let's simplify this. This negative we brought in front. Sine x times sine x is sine squared x minus, and then cosine times cosine is cosine squared x. And this is all over sine squared x. From here, since both of these are being subtracted, I'm going to factor out a negative 1. And this negative can be brought to the front of the fraction. This sine squared plus cosine squared is the trigonometric Pythagorean identity. That's equal to 1. And that's still over sine squared x. 1 over sine of x is cosecant of x. So 1 over sine squared of x would be cosecant squared of x. And this negative is brought down. So this is the reason why the derivative of cotangent of x is equal to negative cosecant squared x. How exciting. Next, let's do the derivative of secant x equals secant x tangent x. Secant of x is defined as 1 over cosine of x. So we're going to take the derivative of that. I'm going to rewrite this 1 over cosine x as cosine x to the negative 1. And now we can take this derivative using the power rule and the chain rule. I'm going to copy down the cosine x, bring this negative 1 in front, and then do negative 1 minus 1 to give me negative 2. Then because of chain rule, I'm going to multiply that by the derivative of cosine of x, and derivative of cosine of x is negative sine of x. So because of the negative 2 exponent, this first term is going to be negative 1 over cosine squared x. And this second term can be written as negative sine over 1. These two negatives can multiply and go away. This cosine squared is cosine times cosine. I'm going to bring one of the cosines over here. 1 over cosine x is secant of x, and sine x over cosine x is tangent of x. And this is the reason why the derivative of secant of x is equal to secant x tangent x. How exciting. And last, let's look at the derivative of cosecant of x. Cosecant of x is defined as 1 over sine x, so we can just take the derivative of that. Since this sine of x is in the denominator, I'm going to rewrite this as the derivative of sine x to the negative 1 power. In order to take the derivative of this, I'm going to use power rule and chain rule. Bring down the sine of x. This negative 1 is going to be brought in front, and negative 1 minus 1 is negative 2. And then I'm going to multiply that by the derivative of the sine of x, which is cosine of x. Since this is to the negative 2 power, this term is going to be negative 1 over sine squared x. And then I can rewrite this cosine of x as cosine of x over 1. This sine squared means sine times sine. I'm going to move one of the signs over here. 1 over sine x is cosecant of x, so negative 1 over sine x is going to be negative cosecant x. And then cosine x over sine x is cotangent x. And this is the reason the derivative of cosecant of x is equal to negative cosecant x cotangent of x. How exciting. And that is how all 4 of those are derived based on the sine and cosine derivatives.